Imagine this. You're staring at a blackboard covered in chalk. Symbols dance across the surface. Equations, theorems, strange Greek letters. They mean something. They describe gravity, time, motion, space. They predict eclipses and guide rockets to the moon. But then a quiet thought sneaks in. Wait a minute, where did all this come from? Not the chalk, not the board, but the math itself. Are these equations human inventions? Little clever tools we built to describe what we see? Or were they already out there, waiting to be found? Would the Pythagorean theorem still exist if no human had ever drawn a triangle? Would the number pi still be woven into the fabric of every circle, if there were no one here to notice? This is the riddle behind every calculation you've ever done, behind every algorithm, every proof, every answer on every math test. Are numbers real? Do they exist out there in some invisible realm, or are they just inside our heads? It might sound abstract, even pointless, but this one question shakes the very foundations of science, philosophy, and even how we understand ourselves. Because if numbers are real, truly real, then there exists a world beyond our world. A place not made of atoms, but of truths. Unchanging, eternal truths. A realm of logic. But if numbers are just inventions, then everything we've built using them, every scientific theory, every technological marvel is just a clever game, a language we made up to make sense of chaos. So which is it? Did we discover math, or did we invent it? And if we discovered it, who put it there? Let's find out. Before cities, before paper, before the wheel, there were numbers, not in books, not in symbols, but in the stars, in the rhythm of seasons, in the steps it took to hunt, to return, to live. The first humans didn't count for fun. They counted to survive, to know how many days since the last rain, how many berries were gathered, how many spears were lost in the last hunt. But as soon as we began counting, something strange happened. We realized numbers had patterns. 2 rocks plus 2 rocks always made 4. 5 fingers were always 5. It was as if reality itself followed hidden rules, and some ancient minds began to suspect maybe numbers weren't just tools, maybe they were truth. Fast forward to ancient Greece, to a group called the Pythagoreans. They weren't just mathematicians, they were mystics. They believed that numbers were the building blocks of all reality, that the universe could be explained, even worshipped through mathematics. To them, a triangle wasn't just a shape, it was sacred. They believed that the harmony of music, the movements of the heavens, all of it followed mathematical laws. And maybe they were onto something. Centuries before telescopes, before satellites, they looked at the stars and saw order, ratios, repetition. It was as if the cosmos itself was whispering in numbers, but not everyone agreed. Another Greek giant, Aristotle, didn't believe in a separate realm of numbers. To him, math was a human creation, a way of organizing what we see, not discovering hidden realities. And this debate between math as invention or discovery has echoed ever since. When Newton described gravity with an equation, did he invent that equation? Or uncover something that had always been true? When Einstein bent space and time with math, was it poetry or was it prophecy? And here's the twist. Even cultures that never met, in Egypt, India, China, Mesopotamia, all found the same math, the same principles, the same numbers. How? How could minds, oceans apart, find the same mathematical truths, unless those truths were already there, already written into the fabric of reality, or maybe etched into something even deeper? Imagine this. You close your eyes. You picture a perfect circle, no jagged edges, no wobble, just pure, flawless roundness. But here's the thing. That circle doesn't exist in the real world. You'll never find it on a coin, or in the moon, or even in the most precise machine. Everything physical is imperfect, always slightly off. And yet in your mind, the circle is perfect. How? Where did that idea come from? This is the question that haunted one of the greatest thinkers in history, Plato. Plato believed that beyond this messy, imperfect world, there exists another realm, a realm of pure forms, perfect ideas, eternal truths. He called them forms or ideals. To him, the physical world was just a shadow, a blurry reflection of this higher mathematical reality. And in that realm, math wasn't something we invented. It was something we remembered. According to Plato, when we discover a mathematical truth, like the Pythagorean theorem, we're not creating it. We're uncovering something that was always there, something timeless, something divine, but not everyone bought it. Fast forward to the 20th century, to a logician named Gödel. He shook the foundations of mathematics. Gödel proved that even in the most perfect mathematical systems, there are truths that can't be proven from within the system itself. Let that sink in. Math, the very thing we thought was the bedrock of certainty, turns out to be incomplete. There will always be truths that logic alone can't reach, and here's where it gets even more strange. Gödel himself was a Platonist. He believed deeply that mathematical truths exist in a real objective way, even if we can't always prove them. He once wrote, "The world is rational, but we can't capture all of it with logic." Think about that. Logic points beyond itself. It's like a ladder that leads to something higher, then disappears beneath your feet. So what does that mean? Are we touching a realm beyond human minds? Are numbers, real numbers, irrational numbers, imaginary numbers, not just symbols on a page, but windows into a deeper order? And if so, who built that order? Because here's the real twist. If math is discovered, not invented, then someone had to put it there. Someone had to craft the harmony, the patterns, the deep symmetry of the universe, long before we ever opened our eyes to see it. So, when a mathematician stares at a blackboard, maybe they're not just solving puzzles. Maybe they're reading scripture. Let's stop for a moment and ask something simple, but strange. Why does the universe follow laws, not just habits or patterns, but exact mathematical laws? Why does gravity always pull? Why does light always travel at the same speed? Why do particles behave like waves and waves behave like particles? We live in a cosmos where the rules don't just exist, they hold, across time, across space, with stunning precision. This isn't obvious. In fact, it's weird, because when you look at nature, really look, it's chaotic. Explosions, collisions, heat, noise, randomness everywhere. And yet, beneath that chaos, there's order, an invisible framework, equations, symmetries, constants, as if the universe is running on code. But who or what wrote that code? Let's take a closer look. The physicist Eugene Wigner once wrote a famous essay called "The Unreasonable Effectiveness of Mathematics in the Natural Sciences." In it, he pointed out something that still stuns scientists today. Why should math, something invented in the human mind, fit the universe so perfectly? Why should imaginary numbers created on paper turn out to describe real electric fields? Why should elegant equations predict particles we haven't even discovered yet? This isn't just convenience. It's uncanny, and it raises a haunting possibility. Maybe math wasn't invented. Maybe the universe is mathematical. Maybe what we call laws of physics are just human translations of something much deeper, a structure built into the very bones of existence. Stephen Hawking once asked, what breathes fire into the equations and makes a universe for them to describe? In other words, equations by themselves are just symbols, but something makes them real. Something gives them power. So, what is that something? Some say it's necessity, that the laws of physics are the only way a universe could work. Others say it's chance, that we just happen to be in one of many universes and ours has stable rules. But maybe, just maybe, it's neither. Maybe it's mind. Not the human mind, but a deeper mind, one that dreamed up the logic, the balance, the beauty, a mind that didn't just watch the cosmos take shape, but wrote its script. Because here's the mystery. The laws of physics are not made of matter. They have no mass, no energy, no location, and yet they rule over everything. They're invisible, intangible, but universal. What kind of thing is that? Maybe not a thing at all. Maybe it's a thought, a will, a signature. We often think of the laws of physics as eternal, timeless, always there, but what if they had a beginning? Let's rewind time all the way back, 14 billion years ago, the Big Bang. Everything we know, space, time, matter, energy, explodes into being from a single, unimaginably dense point. But here's the twist. The laws of physics, the very rules that govern how the universe works, also seem to have started then. In other words, before the Big Bang, there may have been no laws, no gravity, no light, no quantum fields, no rules. So the obvious and unsettling question becomes, where did the laws come from? They couldn't evolve slowly. There was no time yet. They couldn't be shaped by the universe because the universe didn't exist yet. And they couldn't arise from chaos because chaos itself needs a context to be chaotic. Some physicists have tried to dodge this by saying the laws emerged or were selected from a cosmic landscape of possibilities, like random cards dealt from a quantum deck. But that doesn't answer why these laws. Why a universe where matter clumps, stars form, life is possible? Why not a universe with nothing but randomness, or no universe at all? And here's another twist. The laws of physics are not static. Some scientists believe they've changed over time. What if the speed of light was faster in the early universe? What if the strength of gravity wasn't always what it is now? If even the constants can shift, then what are we really standing on? What is the foundation beneath all this? Because if the laws had a beginning, then something or someone had to choose them. This is where physics turns into philosophy, where science hits its limits and wonder begins. Roger Penrose, one of the greatest minds of modern physics, once said, "We are driven to ask the question, what preceded the Big Bang? Where did the structure come from? What governs the laws themselves?" He proposed that perhaps the laws reside in a kind of Platonic realm, a timeless world of perfect mathematical forms. But even then, who or what gave those forms the power to act, to become real? Because at the birth of the universe, something activated the rules. Something struck the match. Maybe it was a fluctuation in a quantum field. Maybe it was a multiverse spitting out baby universes until one worked. Or maybe it was a mind not inside time, but outside it. A mind that didn't begin with the universe, but gave it its beginning. Not with hands, not with noise, but with thought, with law, with logic, with love. Let's look closer at those laws of physics. Not just that they exist, but how they're written. Because the more scientists have studied them, the more they've realized something truly bizarre. The universe is fine-tuned. Not roughly, not vaguely, but precisely, delicately, almost impossibly tuned. What does that mean? It means the fundamental constants, the numbers baked into the laws of nature, seem perfectly balanced to allow for a stable, life-permitting universe. Change just one of them by even a tiny fraction, and everything breaks. For example, if gravity were just a little stronger, stars would burn too hot and too fast. No time for life. If gravity was slightly weaker, stars wouldn't ignite at all, just cold clouds of hydrogen. If the electromagnetic force were altered by 1 part in 10 circumflex 40, chemistry wouldn't work. If the neutron were just a bit heavier or lighter, atoms wouldn't hold together. This isn't science fiction. These are real calculations, published in peer-reviewed physics journals. Respected physicists like Stephen Hawking, Martin Rees and Paul Davies have written extensively about it. Martin Rees even identified 6 dimensionless constants that, if changed ever so slightly, would make life as we know it impossible. The odds, according to many physicists, vanishingly small, as if someone rolled 100 dice. and all of them landed on 6. One popular analogy says this: imagine a universe-creating machine with dozens of dials. Each dial controls a fundamental constant: gravity, strong force, weak force, speed of light, etc. To create a universe like ours, every single dial has to be set just right, not almost right, not close enough, but exactly right. So, how do we explain this? Option 1, chance. Maybe we just got lucky, like winning the cosmic lottery. But really, this lucky. Option 2, necessity. Maybe the laws had to be this way. But if that were true, we'd need a deeper law, a law of laws, forcing these values. But we haven't found such a thing. Option 3, the multiverse. Maybe there are infinite universes, each with different laws, and we just happen to be in one where life can exist, because otherwise we wouldn't be here to ask the question. This is called the anthropic principle. But here's the problem. We have no observational evidence of other universes, and maybe we never will. So this explanation relies not on science, but on speculation. And finally, there's option 4, mind. Not randomness, not necessity, not brute facts, but intention. A reason why the laws are the way they are. Some scientists and philosophers have begun to quietly suggest it, that the fine-tuning of the universe may point to a deeper intelligence behind the cosmos. Not necessarily a man in the sky, but a rational source. A mind that writes reality in the language of logic and math. A creative will that wanted a universe where life could flourish. And that leads us to the next question. If the laws are written like code, then who or what is the programmer? It sounds like science fiction. But more and more scientists, philosophers, and even tech pioneers are asking it seriously. Are we living in a simulation? Let's unpack that, slowly. At the heart of this idea is something surprisingly simple. What we call reality might be code, not metaphorically, literally. Think about it. Everything around you, light, matter, movement, even time, can be described with information, equations, bits, rules. Your brain, a biological processor, the atoms in your hand following predictable laws, the universe, a vast system that behaves exactly like a program. This isn't just a poetic thought, it's rooted in real science. In the early 2000s, Oxford philosopher Nick Bostrom proposed a now famous argument. If future civilizations ever develop immense computing power, and if they use it to simulate past civilizations complete with conscious beings, then the number of simulated realities could vastly outnumber real ones. So the odds that we are the original, slim. We might just be one of countless simulations running on a cosmic hard drive. This isn't a joke. People like Elon Musk have publicly said they believe there's a 1 in billions chance we're not in a simulation. And theoretical physicists have started probing this idea too. Some ask, could we detect the pixels of reality? Just like a digital photo has resolution limits, maybe our universe does too. In fact, at the smallest scale, the Planck length, space itself might be quantized, like pixels in a screen. And time, it might not flow smoothly, but tick forward in quantum frames. Stranger still, when we look deep into quantum mechanics, we find something eerie. Particles don't seem to have definite positions until we observe them. It's as if reality only becomes real when someone's watching. Kind of like a video game that renders only the parts you're looking at. Could that be evidence of a simulation? Of course, there are skeptics. Some argue the idea is unfalsifiable, that it can't be tested, and therefore isn't scientific. But others say we might one day find the code, that the laws of physics themselves may contain signatures, signs of a deeper architecture. And even if we never find proof, the question itself matters, because it forces us to rethink everything. What is consciousness? What is free will? What is the purpose of this universe and our place in it? And if this really is a simulation, who built it? A future human, a machine intelligence, a higher mind beyond space and time? Maybe the simulation hypothesis isn't about computers at all. Maybe it's a modern way of rediscovering an ancient idea, that the world is not self-created, that it follows a design, that behind the curtain of reality something or someone is watching. We've asked what the laws of physics are. We've explored how precise, how beautiful, how strange they can be. But now comes the question that no equation can answer. Why do they exist at all? Why is there something instead of nothing? Why are there laws, mathematical, elegant, consistent, that govern the motion of every planet, the flicker of every atom, the curve of space and time itself? Why this universe is not chaos? Think about it. The laws of physics are not physical things. You can't touch gravity, you can't bottle entropy, they're not material, but they shape all material things. They're invisible scaffolding, logic without substance, and yet they command the dance of galaxies. So, where did they come from? Some scientists shrug and say they just are. But is that really an answer? Imagine finding a fully functioning machine, gears turning, lights blinking, circuits humming, in the middle of a desert. Would you say, it just is? Or would you ask, who built this? Our universe is far more complex, more structured, more mathematically precise than any machine, and still we hesitate to ask the same question. Who or what wrote the rules? Some say necessity. Maybe only certain laws allow for the formation of stars, matter, observers. So we see this universe because it's the only one we can see. All the others, with different laws, collapsed or never formed. Others invoke the multiverse, an endless sea of universes, each with random laws. We just happen to live in one where the numbers work. But here's the twist. Even that explanation assumes a meta-law, a deeper principle that allows multiverses to exist. A rule that generates rules. And so we're back to the same haunting mystery. Why are there laws at all? Why is mathematics woven into the fabric of everything? Why do particles obey equations? Why is the universe comprehensible? Physicist Eugene Wigner once called this the unreasonable effectiveness of mathematics. He found it almost miraculous that math, a human invention, could so perfectly describe the natural world. But what if it's not a coincidence? What if math isn't a human creation, but a human discovery, a glimpse into something deeper, a cosmic architecture, a mind? Throughout history, many great thinkers, from Plato to Einstein, spoke of a hidden order, a logic behind the veil. They didn't all agree on what it was, but they sensed it was there, and maybe you do too. In that quiet awe when you stare up at the night sky, in the harmony of music, the rhythm of nature, the symmetry of snowflakes, in the feeling that everything is connected. If this video made you pause, made you wonder, then you're not alone. We're all chasing the same question as some. Not just how the universe works, but why it works at all. So tell us, what do you think? Are the laws of physics just random, or do they point to something or someone that's greater? Leave a comment, start a conversation. Let's explore this mystery together. And if this journey sparked your curiosity, subscribe, because this is just the beginning. There are still so many questions left to ask, and we'll be asking all of them, one video at a time.